Now I prefer to approach Ohm's law through the concept of conductivity as opposed to resistivity. Okay? Then I'm going to tell you about resistivity, which is just the reciprocal of conductivity. Okay? Simple proportionalities. You know that current density is proportional to what? Electric field. Right? Because that's what accelerates the electrons basically, and they bump into atoms. It's more subtle than that, as we talked about. But, okay? So we accept this, right? And then current is current density times cross-sectional area, right? So current is proportional to E times cross-sectional area. Okay? E is proportional to V over L. In a uniform wire, where it's potential difference in length, right? So current, which I'll call I, is proportional to V over L times cross-sectional area, which is just, I'm going to write it this way, this, and all this is pretty intuitive in terms of what you've already seen, measured, and experienced in the lab. And what we've been talking about all along from the point of view of conductivity. The proportionality constant is incidentally reciprocal of conductivity, which is resistivity rho. So I equals and I have that wrong. Proportionality constant is conductivity, because conductivity is what you multiply your electric field by to get your current density and so forth. So I've got a step ahead of myself, which is not unfortunately unusual. So I'll save resistivity for the next step. Okay? It's conductivity sigma. So I equals V times sigma cross-sectional area divided by length, which you get just easily by, you know, what we've done with conductivity, right? And that's equal to V divided by decide how to write this, rho L over ACS rho is the reciprocal of sigma. Which is resistivity. Okay? And then it is natural to call this denominator quantity the resistance. Because the bigger this is, the less current you get from a given voltage. Okay? Now, as opposed to memorizing Ohm's law by some kind of a mnemonic, there's just a very common sense about it. You're relating three things: potential difference, current, and resistance. Okay? There's an obvious way to know whether you've got it right or not. If your formula tells you that a bigger resistance gives you a bigger current, you know you've got it wrong. And there are other ways it just doesn't work. So you check it against common sense rather than Googling it every time you need to use it, right? And hopefully what you do is you can just reason this whole thing out. So you don't need to Google. So you don't need to memorize something that's otherwise meaningless, and if memorized, could be memorized in the wrong order, because it's a very simple relationship, right? You got to know what's proportional to what and how things change.